In the last tutorial, we discussed the function and injectivity, surjectivity and bijectivity of the function, right? So now we have to do some more question related to injective and surjective function, after that composition of function and inverse function or invertible function, right? So now let us see how can we find bijectivity of some more function of signum type. Let us see if we have a question prove that f natural number to natural number defined by f n is equal to n plus 1 by 2 if n is odd and n by 2 if n is even, right, is onto but not 1 1. We have to prove this function is onto but not 1 1. This function is not 1 1, not 1 1. Not 1 1 is not many one. For more than one element in domain, there must be a single element, single image in its codomain. That function is called many one function, not 1 1 function. The function which is not 1 1 called many one function. So let us see from the mapping. This is natural number to natural number. In this case, if we consider 1 here, 1 is what odd number, we need to put this value here. So f1 can be written as 1 plus 1 by 2, that is called 1 is the element. If you find f2 for the second natural number, 2 is what even number, we have to put in this. So this is 2 by 2 can be written as 1. Same yes. For 1 and 2, for 1 and 2 there is the same image in 1, so this function not 1 1. This is a very well function here. f1 is equal to f2. So therefore f is not 1 1. Can we say that this is surjective or onto function? How can we prove this is onto function? Let us see. Any odd number and any even number, there are different functions for odd and even. Let us consider 2n minus 1 is an odd number and 2n is an even number. Let us consider these are the odd. If for a natural number of n, 2n minus 1 must be the odd number or 2n must be an even number. So now we have to find f 2n minus 1. 2n minus 1 is an odd number. We have to put n as 2n minus 1 plus 1 divided by 2. After simplifying, we will get 2n by 2, that is n. Right? And if you find f 2n, 2n is not even number, we need to put here. So 2n by 2 can be written as n. Since f2n minus 1 and f2n for a general odd number and for a general even number, there is same element in the domain. So we can say that for each and every element in codomain, for each and every element is codomain. What do you mean by the codomain? Second, for each and every natural number, there must be a pre-image in a natural number. If you put 2 here, 1. If you put 3, 3 plus 1 by 2, that is 2. If you put 5, then 5 plus 1 by 2, a natural number. If you put 6, 6 by 2, a natural number. For each and every natural number in the second, in the codomain, there must be a pre-image in the natural number. There must be the pre-image in this domain, that is a natural number. So therefore, we can say that, and we can say that domain, so the range is equal to the codomain. Because n is a natural number and n is a range, and this is equal to the codomain. So we can say that range is equal to codomain, therefore f is onto function. Very important question. You can solve the question related to signum form, even, odd, or multiple of 3, not multiple of 3. You can solve these type of question. related to signum function, right? To find injectivity and surjectivity. Now you can solve each and every question related to injectivity and surjectivity, right? Now we have to discuss about the composition of function. Composition of two or more function. Next topic of the function is composition of function. Let us consider we have two functions f, real number to real number, and g, real number to real number, b, two functions. Let us consider f and g are two functions, both mapping as real number to real number. So let us see, if we consider f as a function real number to real number, this is a function f. Let us see, this is a function f, and real number to real number, this is the function g. Function f and function g are there. Function f and function g. So this real number, this set is called domain of f, and this set is called codomain of f. As well as this set is also called the domain of g, and this is the codomain of this one. So if you consider an element in x, so this element can be written as fx, right? Because this is f. If you consider a general element in this x, so this element must be fx. And if you consider general element in fx in domain, so this element can be written as g of fx. Right? So this function is called GOF. This function is called GOF. This is function GOF. G of fx. So this is the composition of two functions. If you have two functions f and g, you can find GOF. You can also find FOG. If you find FOG, you have to find FOG. You have to write g here, then f here. Let us see. If we consider this function is g and this function f, g and f. Let us see an element in this x. This element is called gx. And if we consider a domain of f, this element is can be written as f of gx. So finally this function can be written as f of gx. This is f of g. This is called GOF and this is called FOG. These are the composition of functions. Very simple, but we need to discuss about the domain and range of this function. How it justified? Let us see. What is the definition of function? For each and every element of domain, there must be an image in this. And for each and every element in this, there must be an image in this. So how can we relate domain and range of f and g with the domain and range of GOF? What is the range of GOF? This one is the range of GOF. This is also called codomain of G. Codomain of G. And what is the domain of GOF? The domain of F. Right? So, the very important concept in this codomain of F must be the subset of domain of G. Then only this GOF exists, otherwise it does not exist. Codomain of F must be the subset of domain of G. This is the domain of G. Codomain of F and domain of G, both are the same set. Either both must be equal or codomain of F must be subset of G. Even we can say that in G we have some extra element also, no problem. But codomain of F must be the subset of G, then only this GOF exists, otherwise it does not exist. If this set is different in F and G both, then GOF does not exist. And in the case of FOG, the codomain of G must be the subset of the domain of F, then only FOG exists. How can we say that FOG exists? Then codomain of F must be the subset of domain of G. Then only F O G exists. This is very important part. How can we say that these are exist or not? Let us see from an example. Very simple. Let R be the set of natural real number F, a real number to real number when Fx equal to x square, and G also a real number to real number when Gx equal to 2x plus 1. Then find FOG and GOF. Find FOG and FOGOF and also prove that FOG is not equal to GOF. How can we find FOG? To find FOG, first we have to check. What we have to check? To find FOG, we have to check codomain of F must be the domain of G. We have to check codomain of F the subset of the domain of G or not. In this case, we have to check the codomain of G in the subset of F. Codomain of F is the subset of G. We have to check this. In this case, this is codomain of G and this is codomain of F. We have to check codomain of the second state G. The codomain of G must be the domain of F. Right? We have to check this one. Very important. So in this case, here this function is real number to real number as well as both are the real number to real number. So codomain of G is equal to the domain of F and codomain of F is equal to the domain of G. Very simple. Both are equal. So FOG and GF both exist. Here codomain of F. To find FOG, codomain of G is subset of domain of F. Domain of F and codomain of F is subset of domain of G. So therefore, FOG and GOF both exists. Therefore, FOG and GOF both exist. Why? Because this is subset of this and this is subset of this. Both conditions satisfied. So we can say that GOF exists as well as FOG exists. Both exist. FOG and GOF both exist. Right? So now we can find FOG. FOG. What do we mean by FOG? FOG can be written as FOG of X. And for the value of X, we can write it as F of Gx. This is F of. What do you mean by Gx? Gx can be written as 2x plus 1. Gx, we have to put the value of Gx that is 2x plus 1. Now you know Fx equal to x square. In the place of x, we have to put 2x plus 1. In the right hand side, we have to also put 2x plus 1. This is 2x plus 1 whole square. We can write it as 4x square plus 4x plus 1. This is FOG. And what do you mean by GOF? GOF. GOF can be written as GOF of X. So it can be written as G of Fx. So this is G of, what do you mean by Fx? Fx is x square. We can put here x square. So G of, do you know x is Gx equal to 2x plus 1? We have to put x square in the place of x. In the right hand side also Gs can be written as, G square can be written as 2x square plus 1. Now let us see. This one is not equal to this one. This is the value of the FOG and this is the value of GOF. So therefore, we can say that FOG is not equal to GOF. Both are not equal. In any problem, if you have to find GOF, you must check this condition. The codomain of F equal to the domain of G. If you have to find FOG, you have to check this condition. Codomain of G must be equal to the domain of F. And if you have to find FOF, then FOF, we can also find FOF. In that case, codomain of F is subset of domain of F. Same thing. So we can also find FOF GOG, FOG, F of G of H, X. FOGOH, X. You need to check this one. These elements, this set must be same, either same or the subset. We have to check this set only. If this set are different in F and G both, then we cannot find GOF or FOG. If the question is F of real number to integers and this is real number to real number, in that case these two are not equal, we cannot find that. If this question is F of natural number to natural number and this is real number to real number, we cannot find that. We cannot find FOG and GOF because natural number is not equal to real number. Right? We can find one thing in here, where natural number is subset of the real number, but real number is not subset of natural number. So we cannot find that one. It will not satisfy this condition. So this condition is very important to find the composition of two functions. You can note down the condition. Now let us see some more example of the composition of the function. Some more example of composition of the function. Let us see. The question is, if you have both real number to real number, then no problem, you can find, you can solve each and every question, no need to check. If both function f and g are real number to real number, that's very simple question. Let us see. To find FOG and GOF, find FOG and GOF when f real number to real number and g also the real number to real number. And the question is fx equal to 8x cube and gx equal to x to the power 1 by 3. It's very simple because you know codomain of g is equal to the domain of f and codomain of f is equal to domain of g. Very simple. Both are real number to real number. It's very simple. Both exist. We can find f of g, that is f of gx. You can write it as f of gx x to the power 1 by 3. You can put the value of gx here, and in the place of x, in fx we have to put x to the power 1 by 3. So it can be written 8 multiply x to the power 1 by 3 to the whole power 3. In the place of x we can write x to the power 1 by 3. It becomes 8x. And if you have to find GOF, then what? G of fx. Then it can be written g of the value of fx is 8x cube. And now to find g 8x cube, we have to put in the place of x, that is 8x cube. 8x cube to the power 1 by 3. That becomes what? 2x. But for 8x cube can be written as 2x whole cube, and 3 is cancelled with the 1 by 3, with 2x. By this we can find the composition of functions. One very important question is this, that is, let f 1, 3, 4 to 1 to 5 and g 1 to 5 to 1, 3 given by f is equal to 1, 2, 3, 5, 4, 1 and g is equal to 1, 3, 2, 3, 5, 1. Write GOF. Write the value GOF. Write the value GOF here. So to find GOF, we have to check the codomain of f must be equal to the domain of g. Codomain of f must be equal to domain of g. Codomain of f. Where is codomain of f? Yes. This must be the subset of domain of g. Yes, both are equal. These are subsets, so we can say that here codomain of the second, that is f, is subset of domain of G. Because both are same 1 to 5, 1 to 5 codomain. So therefore GOF exists. If GOF exists, we can find GF. How can we find GF? What do you mean by F of this one? How can we represent this one? What is the meaning of this? The meaning of this can be written as F1 equal to 2, F3 equal to 5 and F4 equal to 1. This is the value. According to mapping, F1 equal to 2, F3 equal to 5, F4 equal to 1. And in the case of this one, we can write it G1 equal to 3, G2 equal to 3 and G5 equal to 1. Here, 1, 3 means G1 equal to 3, G2 equal to 3, G5 equal to 1. So these are the values F and G. These are the values F and G. We have to find GOF for each and every value. We have to find GOF. So we have to find GOF of which element? 1, 3 as well as 4. GOF for 1. We have to also find GOF of 3 and also GOF of 4, right? GOF1 can be written G of F1. This is G of, what do you mean by F1? 2. And G2 can be written 3. So GOF1 that is 3 and we have to find GOF3 that is G of F3. What do you mean by F3? 5. And G of 5 is what? 1. Very simple. Now, this is called G of F4. F4 can be written as 1. So this is G of 1. What do you mean by G1? 3. So therefore, GOF can be written as a set for 1, 3. This 1, 3 is the order pair. For 3, 1. 3, 1 is another order pair. And 4, 3. 4, 3 is another order pair. This is the value of GOF. According to mapping, we can also solve this question. According to mapping, GOF, this function we can consider F and G. So F can be written as 1, 3, 4 and here 1, 2, 5, right? And G can be written 1, 2, 5 to 1, 3, yes. Now, here 1, 2, 1, 2. Then 3, 5, 3, 5. Then 4, 1, 4, 1, right? And then in the second set 1, 3, 2, 3 and 5, 1. We can also solve this question according to mapping. The final answer will be what? Final answer will be 1, 3, 3, 1 and 4, 3. Right? So according to this, if you have two functions fx and gx in the terms of order pairs, you can also find the GOF. In the case of function, we can also find GOF and FOG. Right? In this case, can we find FOG? Can you find FOG in this case? FOG. Can you find FOG? The codomain of G, 1, 3 is subset of domain of F. Yes, is subset of domain of F. 1, 3 is subset of 1, 3, 4. We can also find FOG in this question. We can also find FOG. Why? Because codomain of G is subset of domain of F. So we can find FOG also in this question. So now you can find FOG and GOF. Both either functions are given or the order pairs are given. We can find both the things, right? So these are the composition of function. Now you can also find FOF. If we have to find FOF, we can solve this, no problem. Now our next topic in this chapter, that is invertible function or inverse function. Inverse function. How can we find inverse of a function and what are the conditions to find the inverse of a function? If you have to find the inverse of a function, what are the conditions required? if a function is injective as well as surjective, means bijective, then only we can find the inverse of that function. Because in the case of inverse, domain and codomain just interchange their places. If we have a function fx, let us see, this is x and this is fx, right? We have some element in this and we have some different element in this. And this is the function fx. What do we mean by f inverse x? Domain and codomain just interchange their places, because this one can be written as y. If you consider this function as y, so what do we mean by inverse? We need to find x in terms of y. So f inverse x, f inverse y can be written as x, f inverse y can be written as x can be written as f inverse y, f inverse y can be written as x, and this function is y. Just interchange, inverse function interchange their places. So domain and codomain just reverse. So in that case, the function must be one function. Why? Because for each and every element of its domain, there must be a unique image in its codomain. If the function is many one, we cannot find inverse of that function. Let us see. If we have a function of many one function, let us see many one function. This is the many one function. This is a many one function. Can we find inverse of this function? In the case of inverse, these both are just reverse their places. Reverse means this one. Reverse. Is it function? For one element there are two images. For an element in domain there are two elements in codomain. This is not the function. This is not satisfy the definition of the function. So the function does not exist. In the case of many one function, in the case of many one function, we cannot find the inverse. In the case of many one function, we cannot find the inverse of that function. For to find the inverse of a function, the function must be one. Why it is on to? Why? Because if you reverse this one, if we have some extra element in this, in codomain, if you reverse their places, so in that case, we have one remaining element which don't have any image that not satisfy the definition of the function. So therefore, this is very important, the very important condition. According to mapping, we can say that a function is invertible only when the function is 1 and onto. You can also say that the function must be bijective. A function is a bijective function, that in that function we can find the inverse of the function. That function is invertible. If a function is not invertible, we cannot find the inverse. If a function is not invertible, we cannot find the inverse. We can find the inverse of function only when that function is bijective function. To find the inverse of any function, first we have to prove that that function is injective as well as surjective. Then only we can proceed to find the inverse of that function. One more second condition also to find the inverse, if the function FOF is the identity function. If FOF is the identity function, in that case we can also find the inverse of the function. FOF. If we have a function given and you can find FOF, and that is identity function, means FOF of x is equal to x. That is the identity function. In that case we can also find the inverse. So this is one of the conditions to find invertible function or inverse of function, and that is the second condition. So the first condition is very important. If you have to find inverse of a function, you must check the bijection of that function. Then only you can find the inverse of that function. Let us see some very important questions that already asked in the CBSE. The very important question. Let let f natural number to real number be a function as fx equal to 4x square plus 12x plus 15, so that f natural number to the range of f is invertible, and find the inverse of f. To find the inverse, if the question it is not given that they find the invertible function, prove that it's invertible, then we have to prove that the function is invertible. If you have to find inverse of a function, you must prove the function is invertible or not. To find the invertible, first we have to check the injectivity and then surjectivity. Injectivity, let us consider fx1 is equal to fx2. So we can write it as 4x1 square plus 12x1 plus 15 is equal to 4x2 square plus 12x2 plus 15. Simplify this one. 15 cancel 15. We can write 4x1 square minus 4x2 square plus 12x1 minus 12x2 equal to 0. We can take 4 as common, 4 common, it can be written x1 square minus x2 square plus 12 common, x1 minus x2. Now you know the formula for x1 square minus x2 square, we can write it as x1 minus x2 plus into x1 plus x2. So we can take 4 x1 minus x2, x1 plus x2 plus 12 multiply x1 minus x2. We need to prove x1 equal to x2. So we can take 4 x1 minus x2 common, remaining part we have x1 plus x2 plus 3 is equal to 0. Now for every natural number, here the function natural number to real number, so x1 x2 must be the natural number, that is the part of the domain. So x1 x2 must be the natural number. For since x1 and x2 belong to the natural number, so for each and every natural number this function cannot be 0. These two are the natural numbers, sum of two natural numbers added with 3 cannot be 0. So therefore we can say that x1 plus x2 plus 3 cannot be 0. Therefore 4 multiply x1 minus x2 equal to 0, so x1 equal to x2. We prove this one, therefore fx is injective, right? And to find the surjectivity, we must prove the range of the function is equal to the codomain of the function. So, in the second case, we have to find surjectivity. To find the surjectivity, we must prove. To find surjectivity, we must prove the range of the function is equal to domain. So, is equal to codomain. So, let us consider fx as y. So we can write it as y equal to 4x square plus 12x plus 15, right? So we have to write x in terms of y to find the range of this function. So we can write it as 4x square plus 12x plus y minus 15 equal to 0. We have to write x in terms of y. By quadratic formula, we can write x equal to minus 12 plus minus square root of b square, that is 144 minus 4ac, that is 16 y minus 15 divided by 2a, that is 8. So x can also be written as minus 12 plus minus square root of, if you consider 16 as common, it becomes 4 root, you can take 16 common, it becomes 4 outside the square root. It becomes 9 minus 5 plus 15 divided by 8. So therefore x can also be written as minus 12 plus minus 4 multiply, or we can take 4 common to cancel the denominator. We can write it as minus 3 plus minus square root of 24 minus y divided by 2. X in terms of y, this one. Square root of 24 minus y by 2. Right? Let us check our calculation. If we shift this y left hand side, it becomes 15 minus y, I think. 15 minus y, not y minus 15. 15 minus y. So we can write it as y minus 6, right? We have to find range of this function here. The square root function cannot be negative, so we can say that y minus 6 is greater than equal to 0, so y is greater than equal to 6. So therefore range of this function is 6 to infinite. The range of the function 6 to infinite, and this is the codomain of this is the subset of its codomain, real number. This is the subset of its codomain. It's very clear, so that n tends to range of the function. Range of the function is what? 6 to infinite. Means the question is natural number 2, 6 to infinite. Prove that function natural number 2 range is invertible. Yes, it is invertible because now range is equal to the codomain. This is the codomain of the function. So therefore, the range is equal to the codomain. So f is surjective. And this function is injective as well as surjective. So this is invertible function. So we can say that this function is invertible. And if function is invertible, we can find the inverse. So therefore, f is invertible. Find the inverse of, what is the inverse of f? Very simple. This is only the inverse of f. You have to write y as x and x as f inverse x. So therefore, f inverse x can be written as minus 3 plus minus square root of x minus 6 by 2. This is the f inverse. What do you mean by f inverse x? If you write x in terms of y, that is only the f inverse x. If we have a function fx equal to x square, what is f inverse x? Root x. You have to write x in terms of y. If you write x in terms of y, that function is only the f inverse of x. So this is f inverse x. So in each and every question related to inverse, you must check the injectivity and surjectivity in that. If the function is bijective, then we can find the inverse, right? So this is one of the very important question for CBSE. Is asked in the 2010 board exam. You can also solve the question related to rational function, square root function, modulus function, polynomial function in the case of to find the inverse of the function, right? So let us see from one more example. The question is if q to q, this rational number to rational number is given by fx equal to x square, then find f inverse 9. Can you find f inverse 9 here? It's very simple. You have to find f inverse 9. So first we have to find f inverse x, since fx equal to x square, so x equal to root fx, so therefore f inverse x equal to what? Root x. So therefore f inverse 9 is equal to what? Root 3. root 9, that is called plus 1. Very simple. This is the value of f inverse 9. Very simple. You have to find f inverse 9. To find f inverse 9, you have to find f inverse x first. Right? I have to find f inverse of this function. This function must be injective as well as surjective for rational number to rational number. Yeah, it is a bijective function. No problem. Now, let us see fx. This question asked me 2 times in board examination. If fx equal to 4x plus 3 divided by 6x minus 4, where x is not equal to 2 by 3, prove that f of x equal to x. What is the inverse of f? Very simple question. This is the second condition to invertible function. There are 2 conditions to check the function is invertible or not. If the function is bijective, that must be invertible. In another second example, is second case is if you check the f of f is equal to x. F of f is identity function. Then we can also say that that function is invertible function. In this case, we have to check f of f is equal to identity function. Identity function is what x. Then we can also say that this function is invertible. If you prove f of f is equal to x, then we can say that this function is invertible. No need to check injectivity and surjectivity if we check that f of f is equal to x. Right? So, in this case, f of f x can be written f of fx. We can write it as f of 4x plus 3 divided by 6x minus 4. Right? So f of this one, in the place of x we need to write this value. We can write 4 multiply 4x plus 3 divided by 6x minus 4 plus 3 whole divided by 6 multiply 4x plus 3 whole divided by 6x minus 4 minus 4. Simplify this one. It becomes 16x plus 12 plus 18x minus 12 divided by 24x plus 18 minus 24x plus 16. You can cancel this one, and 12 and 12 you can write it as 16 plus 18, 34x by 34, that means x. Yeah, we proved that f of x can be equal to x. Now we have to find the inverse of this. So therefore, since the f of x is equal to x, so therefore we can say that f is invertible function. F is invertible function. So therefore f is invertible function. If f is invertible function, we can find the inverse. So therefore fx, let us consider y equal to fx, and we need to write x in terms of y. That will be the inverse of the function. If we write x in terms of y, that will be the inverse of the function. So in this case, we need to cross multiply this 6xy minus 4y equal to 4x plus 3. It can be written as 6xy minus 4x equal to 4y plus 3. We can take 6x as common. 6y minus 4 equal to 4y plus 3. So therefore x can be written as 4y plus 3 by 6y minus 4. Now we written x in terms of y. So what is the inverse? Therefore inverse f inverse x can be written as 4x plus 3 divided by 6x minus 4, where x is not equal to 2 by 3. Why x is not equal to 2 by 3? If you put x at 2 by 3, it becomes 0 and denominator cannot be 0. It's very simple question. This is the second condition to find the invertible function. Not very clear how to find the invertible function, how to find the inverse of the function. So these are all about the function. Now you can solve the question related to functions. Now in previous classes, previous tutorials, we discussed about the relations and the function. You can solve each and every question related to the function, inverse of the function, composition of the function, right? In the next tutorial, we discuss the binary operation. That is one more important topic in the relations and function. Thank you.